hi everyone. Thank you for the great introduction. So, my name is Bruno. I'm a front-end developer at Cineta, and you can find me on Twitter and GitHub. So, we are developers, and our goal is to create amazing apps and websites. And if we check out one of these sites, we can find these award-winning websites. And they are great, people like them. But what they all have in common? So all of them, they have animations. So they have elements that move, change, interactive components. And when the animations are done well, the animation can really amaze us. And not only amaze, but animations has the potential to communicate in the different level, grab the user attention, reduce the cognitive load. But why some animations are good while others are bad and annoying? So this question, why, was haunting me. Because it's just a matter of how it feels. Is this the only accurate measure tool that we have? So it's like, yeah, I like this animation. No, that's annoying. So I want to know why. So I decided to do some research, and I found this website, Google Material, more specifically, the Material Motion. And if you don't know this website, check it out. It's super cool. You will find nice guides, explanations. It's super cool. But once again, I found this here. So in Google Material, we can find animations like this one. And this looks like OK, but actually, no. We shouldn't do that. Why? Then there you will find just a small sentence explaining why. But I want to know more. And then we can find another example like this one. It's a little bit more complex, a lot of things going on. But in this case, it's a do. We should do that. But again, why? And we can just find a small paragraph explaining. But I want to know more. So I decided to go deeper and starts with the basics, with this question. So what is animation after all? And by the definition, animation is the technique of producing the illusion of movements by displaying a series of images or frames. So we can simplify this a little bit more. So animation is the illusion of movement. So animation, it's just an illusion. And for me, this was like an aha moment, because since it's just an illusion, it doesn't matter the technique. If you are using React, Vue, Angular, or animating with CSS, a div towards spam, canvas, it doesn't matter. Our goal is just to create great illusions. And one illusion, by definition, is the wrong perception of a sensory experience. So we need to create this wrong perception. So we need to fool one organ of our body. It's not the eyes, but the brain. Because the vision has more to do with the brain than with our eyes. So in order to understand this a little bit more, it is true that our eyes capture the lights, but this information, and we can see in this image, the eyes capture this information and send to the back of our brain, to the visual cortex. And just to have a little idea, the work involved here, there is more than 30 different zones just to analyze and process the image. For example, we have a specific area just to see the contour or the shape of the objects. We have a different area just to see in colors. And we have one dedicated area for, guess what? Animations. So can you point which area is this? So is this little guy over there. It is called MT. That stands for middle temporal, or also known as V5. So this is where all the fun is. So in order to create these great illusions, we need to fool the MT. So here is where we need to look to create these amazing animations. But how this area works? Just a disclaimer here, I'm not a scientist, but I did some research and I found quite interesting and I want to share with you. So, if you take a look on this example, this is what MT sees. So there is no color, just black and white. And each of these dots represents one neuron from our brain. So this is like a static image. But what happens if something passes through our eyes? So I will click here, so it will happen something like this. The neuron will fire. And if something is moving, the neighbor will fire, and this is just, and we need to remember that this is just individual neurons, individual information. But in order to see motion, the brain, the MT, needs to perform a lot of calculations. So it's something like this. So what our brain needs to do is to calculate based on the position of each neuron, and the time passed needs to calculate the direction and the speed of the motion. So it's something like this. It will create like a vector field. So when it's very slow, the vector is small. When the motion is faster, it will create like a faster motion. And our brain is doing this for everything that moves in front of us. So our GPU is working all the time, performing all these calculations. And do you want to see how important these calculations are? So I want to do with you one small experiment. So I want you to hold your head still, like this, and try to move your eyes from left to right, but without moving your head. And try to move the eyes very slowly, the smoothest that you can. And you will notice that our eyes will do like small jumps. Can you notice? So these small jumps, it's called saccades. So we cannot actually do a very smooth movement. But now, I want you to do the same, but hold your head, and now move your finger in front of you and try to follow your finger. Can you see? And now, it's much smoother, right? So what's going on here? So when MT performs this calculation, it can predict the path and the vector, and the information, these calculations, is sent back to the eyes as motor signals or eye movements. So the information is sent back to our eyes. And by doing this, we can follow objects very smoothly. But people that suffer some injuries in this area, they lose this ability. Also, alcohol can affect that. So I have another experiment to do with you. So later at the bar, after drinking, record your face and move your finger. If you cannot follow your finger smoothly, congratulations, you are drunk. So this night feature, it's called Smooth Pursuit. So it's called Smooth Pursuit, and try to memorize that. We'll come back later for this. So every time that we have an animation, there is a vector. So if there is a translation, try to see this vector. If there is a fade out, fade in, try to visualize these in visual vectors that our brain needs to calculate. So all the movements will create these vectors. So the more arrows do we have, the more brain power is necessary to calculate all these movements, and less pleasant the animation becomes. But our brain has a way to optimize these tasks. So adding easing, it will help, but also our brain will do something like this. So let's suppose that we have two movements, two motions at the same time, one 45 degrees up and other 45 degrees down. What the brain will do is will create the average between the motion. And the brain is doing that all the time. And we have another experiment to see how can we notice that. So as we can see here, we have random particles moving different directions, but 20% of them are moving to a specific direction. So can you notice what is the global motion here? So if you think that these 20% of particles are moving to the right, please raise your right hand. If you think they are moving to the left, raise your left hand. Okay. Is it right, left? Okay, cool. I will help you. So they are moving to the right. Congratulations. If you said left, you are drunk. Okay, so this ability to calculate the average, it's called global motion perception. And how can we apply that in our animations? So we have here another example from Google Material. And they say that we need to do this. It's a nice animation, like a staggering. But we should avoid this one. Why? Now we know better. So because in the first example, there is just one smooth vector. It's very easy to notice the global motion. While here, even though it's in the same direction, because of the delay, we can notice like multiple tiny vectors. So we should always aim to connect them to create just one smooth animation. Also, now we have this one, and we can know why this is bad. Because all the directions that they are moving, we cannot say what is the global motion here. We can clearly tell what's going on. And then we have this example here again. And so how can we understand this example? So in order to understand, we have here another experiment. So here, let's try again. OK. So here we have particles. But in this case, we don't have a global motion. They are just random particles. But I will add something here. So I want you to follow the red dot. And you will notice that while we are following the red dot, suddenly the background movement seems to stop. And when they are slowing down, we start seeing the movement again. Can you see it? So when we follow, the background movement seems to stop, right? So what's going on here? Well, remember smooth pursuit when we are following one object? So when MT engages the smooth pursuit, then the background vector calculations are turned off. So how can we use that? So every time that we need to create a complex animation, like a page transition, we can give something to the user to focus on. So this will disable the background animations and the vectors, and will become more pleasant, and less cognitive power is necessary to process this image. But now, let's try something different. So let's suppose, in the brain perspective, we are looking to an animation like this. So in the real world, it's not really common that all the objects start moving at the same time, right? It's not really common. So in the brain perspective, when everything is moving at the same speed, it's perceived not as one object moving, but maybe we are, in fact, moving. So this is called self-motion. So it is perceived as self-motion instead of object motion. How can we use this? Well, we can create things like page transitions, navigations. And this happens when we move a big part of the screen. It is super useful to create special navigation. So by doing that, the user has this feeling that he is now in a different position of the application. But when we move big parts, we need to be careful, because this is a great power. But as we know, with great powers comes great. And that's true, because our animations can make people sick. So just by watching our animations. And there is a condition called vestibular disorder that people with that can feel loss of balance, vertigo, migraines, nausea. So this could be a real problem. But how can we avoid that? So something that we can do is try to avoid animating big parts of the screen. Adding something to focus could help. Also, we should avoid any big rotations. Why? Because it's natural to move our heads like this, horizontally, vertically, but we never do like these rotations. Maybe when we are in a boat, but people get sick in the boat too. So we should avoid this kind of big rotations. Also, long transitions, we should keep it short. Avoid big transitions in relation to the viewport. And also, we always should give an option to reduce motions or turn off certain animations. There is a media query for that. It's called a reduce motion media query that we can use. So, can we remember these brain features? The first one that we talked about was this smooth pursuit. So if we give something to the user to focus, this will be much smoother and could give a better sense of direction. Also, it's always good to see in vectors. So every time that we are animating, try to see these invisible vectors that our animations create, and try to keep it short in distance. Also, remember global motion. We should try to connect these vectors, and should it be very clear. We should know what is the global motion of my animations. And we need to use spatial navigation to create things like navigation, but very carefully avoiding big portions of the screen. So now, by understanding a little bit more how the brain works, we can understand why some animations are bad and why we should avoid them. But how can we create and build these animations? There is a lot of tools. I've created this ReactiveConf to simplify the creation of complex morphing animations when we need to transform one element into another. But you can also use React Pose. I recommended this one. They have like a simple API that you can use. Also, Popcorn from PopMotion to create vanilla animations. And React Spring, it's also nice. And if you want to know more, I recommend this book from Valhead. It's Design Interface Animations. And in order to understand a little bit better how the brain works, there is the work of the neurobiologist, Professor Bill Nielsen. So now what? So let's animate more. So do more experiments. Share your knowledge. Try new tools. Communicate with your team, with the designers. And because after understanding the why, we can be more confident. And people like animations. So please add more animations to create amazing apps and websites. Thank you.
Thank you, Bruno. Great talk. I feel like there's going to be a lot of people later tonight with their phones just giving the thumbs up, completely drunk. All right, let's have a look at some of the questions. What is your favorite tool for prototyping animations?
Yes, like I said, I really like PopMotion Pose. They have a super easy API that you can use, very declarative. You can define the one state and the other, and then you can toggle between just changing the state. So it's super cool.
Great. Next one. How do fade-ins and outs translate into vectors?
Exactly. So the thing is that even though when there is no a transition, a real object moving, if we do like a fade out here, a fade in here, there will be this sense that something is moving from here, from that direction to that direction. So it always will create that. So if we fade out here, fade in here, then here, we can automatically see like a vector going this direction. So it's always good to try to focus and try to use that in a functional way. So if we want to grab attention for one specific direction, then we should use this vector in our favor.
All right, next one. From me, what do you think about Reactive.js background animation?
Okay, yeah, that's a good one. So we were talking about the one that appears in the...
Definitely asking the wrong person, mate.
Yeah, I don't think Reactive.js. I don't know what it's about.
You'll have to find him in the break. We'll move on to the next one from John. What do you think about using animations and website accessibility for users with eye defects? Do you have some tips and tricks?
Yeah, so like I said, there is this condition, vestibular disorder, that we should avoid big transitions, also animation that starts automatically for more than 5 seconds, and we should give options to disable them. But people with eye defects, so if you are blind, the animations makes no sense, right? But animation itself cannot remove the accessibility. So if you create like a good markup with good accessibility, then you are covered, basically.
All right, your opinion about flip animations.
So it's awesome. ReactMorph, it's using that. So it's a good way to keep your code simple in the way, in this case with ReactMorph, I'm just using 2 states. One state that we can declare it easily, and then the other state. And all the transition in between is just elements that are created and doing this flip animation. So if you don't know how this works, basically, we need to calculate the target position, and then we animate from the initial position to the target. So it's super cool. If you don't know, please check it out.
All right. If the device is not powerful enough to do smooth animations, is it better to turn them off?
Yes, because, once again, because of the brain. Because our brain will try to always see things like we see in the real world. So we should always aim to have a good frame rate. There is some techniques you can control, like the frame rate, and if you can reduce, let's say, the complexity, like reducing particles or big elements, then we can use that in our favor. But if the frame rate isn't good, so we should avoid it.
All right, next one. Can usage of pastel colors help to make better transitions?
That's an interesting one. I never thought about that. Yeah, I don't know how this could work in terms of how can we perceive.
Food for thought. All right, maybe time for 1 or 2 more questions. How did you learn all this animation knowledge?
Yeah, I searched the web, and there is very good resources. There is some sites that you can search for papers online. You can search YouTube videos, and there is some examples that's similar to the ones that I showed, but they use like some videos or GIFs, and all these examples that I did was with points.js to be interactable. But there's a lot of resource online that if you are interested enough, you can search and you'll find some very good stuff.
Fantastic. Thank you, Bruno. Let's all give him a round of applause.
Thank you.